Everyone, I'm Wan Lee. I will open new chapter 3, sample and distribution of X bar. Okay, this chapter is very important to understand statistics. So I've changed thumbnail by fireworks like this. Okay, let's see what is the uh, theoretical sample. It is very important because it forms the foundation for starting statistics, theoretical sample, okay? If you do not have a proper understanding of the theoretical background regarding samples, it will be difficult to build a foundation in statistics. Statistics is a very simple discipline if the foundation is well understood. Statistics starts from now. Many persons say statistics is pretty hard to understand, even though they studied statistics, okay? But it is not true, of course. Statistics is easy and very simple, okay? If you understand this chapter, sample. In the first lecture, at the beginning, we defined the data obtained with the specific values as a sample. This is a specific values, observed values, small letter, x1, x2, xn, right? It is real numbers. It was also mentioned that behind the sample, there is population, right? So sample you get from population. However, understanding the sample only n measured values like this is not sufficient for properly grasping the foundational theories of statistics. Unfortunately, many textbooks do not point out this one, the following one. Okay. It is important to understand a sample as n random variables. This one. Okay. You have to understand this one, n random variables. A sample is a sample. Okay. In other words, when a sample of size n is obtained from population X, if we denote the first value will be obtained as x1. Okay, population here. What? X here. Population means random variable X. So there are many X's here, right? Unknown values. So first value obtained x1. Second value will be obtained x2. Last one, xn, nth value will be xn. Still, we do not know the values. That's why I say theoretical understanding about sample. Then we can understand the sample consists of n random variables, so sample can be defined by this way. Okay, this is a sample, theoretical sample. Of course, the specific values obtained in practice represented as small letter x1, x2, xn, real value, okay, realized values, is also said to be a sample. This one is a sample. This one also called sample. Let's see briefly. Diagram. There is population. Population, we can denote it by random variable x. If you have a random variable follows a certain probability distribution function. Okay, so we take a sample from this population, small letter, x1, x2, xn, small letters. Specific realized values obtained from the population in practice. I repeat it. Okay, see, another view is sample. I told you can be denoted by random variables x1, x2, xn, like this, okay, and random variables. There is a survey step. Through survey procedure, we get real numbers, specific values, x1, x2, xn. This is also sample, measured values of n random variables. N random variables, its realized value is a small letter, x2, realized value, small x2, xn, small realized value, x small letter xn. This sample represented by n random variables is sometimes denoted as this way: x1, x2, xn tilde IID f of x. IID abbreviation is independently, identically distributed. Okay? Independently. You know, independently. Sample value sample values are independent. Okay? And identically. Oh, what? Identically what? F of x. It follows random variable, n random variables follow this distribution. What is this? The population x. Okay? Distribution. Xi follows the same distribution f of x independently. Okay? Get it? Oh, you may ignore the subscript. This one, x1, x2, 1, 2, 3, n. It's just mean of representing sample. You can ignore subscript I. Okay? So actually, sample is n xx dot dot x there n. Okay. This one is a sample. Take x, 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 and many x's. But we have to distinguish single x and subscript x1, x2, xn. That's why this one is what? Just denote, just indicate sample. So you may ignore this one, x1, x2, subscript xn. Then xi follow the distribution f of x, and samples are independent. Okay, it is simple but important. You have to understand the contents of this page, otherwise you cannot follow the next coming content of statistics, and you cannot understand statistics well. Okay? Okay. Thank you. Bye.